Hi, my name is Chi, and I majored at Concordia Political Science and Math.
And my name is Kayla, and I'm majoring in math at Concordia.
This summer, we work on something called the secretary problem with Dr. Work in the math department.
The secretary problem outlines a scenario in which you're a hiring manager looking to hire a secretary. So you interview a fixed number of applicants. The interviews are conducted in random order, and you must decide whether to hire or reject the candidate before the next interview. Once rejected, you can't go back and offer the position to a previous candidate. Each candidate gets a unique rank relative to the rest of the previously interviewed candidates, where 1 is the worst candidate and n is the best candidate. The main question is, what is your probability of hiring the best candidate?
So the well-known strategy for the problem is the 37% rule. That means you have something called the training set, which is 37% of your pool of application. In the training set, you interview and reject every candidate and keeping track of who the best so far. After the first 37%, you accept and hire the first candidate that better than the best candidate in the training set. This strategy works 37% of the time, which means that you hire the best candidate overall 37% of the time.
In our project, we focused on changing some of these conditions, specifically the random order condition. We looked at some strategies such as permutation avoiding, strike strategies, and consecutive permutation avoiding that change the randomness of the interview orders. Our main goal was to think about how these changes affect the probability of hiring the best candidate.
Our work depended on looking at the ranking list after each interview, which basically gave us a list of numbers that we used to look at the tree of all of the possible ranking lists and work out probability of success for different candidate pool size.
One of my favorite things about research was being able to use different types of visualizations to think about generating possible ranking lists. My favorite was a one-to-one correspondence between the number of permutations when avoiding a length-3 pattern and dig pass. We also had fun making tree diagrams. Personally, my favorite tree diagram was the S5 tree, which contains 120 length 5 permutations. That's a lot of permutations.
We also have a chance to develop many of our skills such as reading and researching by looking at journal articles written by researchers in the field. With the information collected from these articles, we were able to modify the problem with known solution and then think about how those changes can alter the result, especially with the win probability.
Thanks for watching.
Bye!